Hi there guys, got a video here for you today on the BSA R12, and in this one we're going to be making an extended pellet probe for the rifle. Now just to bring everyone up to speed, we're making an extended probe because I believe the original one wasn't pushing the pellets far enough into the rifling, and I believe this was causing us some inaccuracy issues. What was happening is that the pellets were about 2 or 3 mil shy of the rifling, so when the air was applied to the back of the pellets had to find their own way into the rifling rather than being seated there nice and evenly. So we're going to be making an extended one just to push the pellets a little further into the barrel. We've got some stainless steel chucked up in the lathe, and we've just faced the end, put a centre drill in the end for a centre, then turned down the OD to just over 9mm. What we did then was pull the stock a little further out from the chuck, then part the piece off a little over size. The probe itself is going to be about 75mm long when all's said and done, so we're giving ourselves about an extra 10mm just so we've got some working room. Once we've parted it off, we can flip it round in the lathe and start work on the shank end. So this will be the end that travels through the magazine and actually pushes the pellet into the barrel. This end needs to be turned down to about 4.8mm. And again, we are using some tailstock support. Once we're down to near our finished dimension, we can change out the insert and just put a nice finish on the material. But once we've got our shank down to dimension, we can put the shank in a split collet and just use a grooving tool to create the O-ring groove. We're using a split collet in this application to get the grooving tool nice and close to the chuck. This just minimises any chance of the work grabbing and either breaking an insert or scrapping the work. We are going to be using the same size O-ring as the original, although in this pellet probe we are making the groove slightly shallower, and that will just give us a better squeeze on the O-ring inside of the barrel. The original one just about seals, and with a magazine in there you do feel a very slight blow from the transfer port area. I believe this is because the magazine is forcing the probe over to one side, and then the exposed side is just letting a little puff of air through. So hopefully a tighter O-ring will fix that. The last thing we can do in this setup is put our tailstock support back in, turn down the end using a 45-degree chamfer tool to create our probe profile. This is going to be a pin probe, so we're using a 45-degree chamfer tool just to create the initial lead. With that done, we can flip the part round in the lathe, holding it by the extension at the end of the work, and then part it off. This is why we cut the probe oversize, as parting off this little end piece of material would be quite tricky with the entire length of the work exposed. But we're just using our grooving tool to part it off, and the rear of the pellet probe is just supported in a drill chuck. With that all done, that's all the lathe work complete. We can move the piece over to the mill. So we've got the pellet probe set up in a 4-sided collet block, the collet block itself being propped up on some spacer pieces and then held in place by a strap clamp. We are going to be milling and drilling on all 4 sides, so we need an accurate way to index the part in the vise. We're starting on what would be the bottom of the piece, and on this side we first need to create some centre marks using a centre drill, then come back through with a 2.5mm drill bit and drill these holes out. The hole closest to the collet block will be tapped M3, and this hole will be for the cocking dog. The other hole needs to be drilled out to 4mm, and this is where the cocking pin will sit. With that done, the next thing we need to do is mill a little groove on this rear hole, and this groove will allow us to install an E-clip. Unfortunately, whilst carrying out this operation, I did actually come in contact with my vise. I did measure the piece before I started, and I thought I had a little bit of clearance there, but on the final pass I just come into contact with the vise. It's not a big deal, but it is slightly annoying, so all I had to do was prop up the piece using just some shim spacers just to get us a little bit of extra clearance. Before we take the piece down to final depth though, I did have to re-zero my Z-axis on the cocking dog hole. This hole did have to be counterbored anyway, so it's not a big deal. So we just use the 6mm end mill to counterbore the cocking dog hole, and then move back onto the groove and finish out the groove to final depth. With that done, we can flip the probe 180 degrees and finish off the other side by just counterboring the pivot point hole. Next up, we can flip the piece 90 degrees and start working on the left side of the probe. On this side we need to spot and drill a 1mm hole, and this hole will allow us to attach the small return spring in the pellet probe. With that done, we can use a spot drill and a 2mm drill bit just to drill out some of the waste material from the back. This back side of the probe is going to be slotted, So by drilling out some of the waste material, it just makes the end mill's job a little easier. On this side, we need to mill the slot just shy of the 1mm hole we drilled earlier. With that done, we can flip the part 180 degrees in the vise and finish off the other side. This side slot needs to be a little longer and match up with the slot we milled in the other side, so it's not to full depth, as there is a small step in the pellet probe. You'll see exactly what I mean when I give you a little close-up of the pellet probe on the bench, but we're just using a 3mm 2-flute end mill, stepping down nice and slowly and using a lot of cutting oil. Unfortunately, I didn't have any coated end mills, so this one is just an uncoated carbide end mill, but taking nice shallow cuts, it produces a wonderful finish. With that all done, we'll take you back over to the bench and get you a good look at the finished component. Right then, and here are the two probes. So this is our new one. As you can see, it's turned out fairly well. I'm quite happy with how it's turned out. Did give it a quick polish on the lathe, just using some wet or dry sandpaper. But as you can see, we've got all the components attached. Cocking arm, small return spring over here, cocking dog on this side, as well as the small O-ring at the front there. The only thing I did off camera is just change the angle of the front there, so it's a slightly shallower angle than the 45-degree chamfer tool that we used earlier. What was happening is that as you pushed the bolt forward, the actual angle itself was catching on the magazine, and as the 45-degree was fairly aggressive, it was a little difficult to push the probe through the mag, so we just changed that to a nice shallow angle. Other than that, if we bring the barrel back, you can see that we've made a small mark on the side of the probe. Hopefully you can see that there, just a small pen mark. So we'll push a pellet in using the probe and we'll see how far it gets seated. So we'll take a pellet, push that in the end there, just a standard 844 pellet. Then we'll use the probe very carefully to push it in. As you can see, the pellet is now hitting the rifle in here. Then we've got another 2mm to go or so that the pellet is nice and seated. There is a very small taper to the rifling, so as the head of the pellet goes into the rifling, the skirt of the pellet does contact the rifling as well. I very much doubt if the camera will pick it up, but we'll take a look down the end there, and hopefully you can see that the pellet's nice and seated within the rifling. Probably not, but you'll just have to take my word for it. You can see rifling marks on the skirt of the pellet. If we take a rod and just rod the pellet out the end, this is just a nylon rod, nice and carefully. You can then take a look at the pellet, and as you can see there, really nice small witness marks on the head and skirt of the pellet, so we've got no damage or anything like that. The only other change that I've made to the barrel is I've redone the 1/2 inch UNF on the end, so I've just sleeved it, cut a new 1/2 inch UNF on there, just so we've got a full 1/2 inch UNF rather than the little stubby one we had on there before. With that all said and done though, what we'll do now is take you downrange and I'll show you the results. Right then, and here we are all set up in Pete's airgun farm in the 50-yard range. We've got an A4 target set out on the back wall with a number of circles printed onto it, these circles being 25mm in diameter with a red dot in the middle. We're using the R12 using JSB 844 pellets to create 5 shot groups in each of the targets, and we'll take a closer look at the results on the bench a little later on. And I do want to mention that all of these groups here were done using the magazine. The rifle is better with a single shot loader. However, all the other tests were done using a magazine, so we're using a magazine in this one just to keep everything nice and fair. With that all out of the way, I'm quite pleased with how the rifle's now shooting. If it shot like this straight out the box, I'd have been rather happy. I still might rebarrel the rifle as I believe it's got a little more to give, but I do want to have a good look at the magazines and all the rest of the components of the rifle before I go ahead and do that. At the moment, the original barrel is shooting rather nicely and I am pleased with the results. Now, as the groups are appearing on screen, I did very briefly want to mention that a good friend of mine has recently bought an Ultra CLX. Now, he's let me have a good look over the barrel and the results are quite surprising. Now, I will mention that the barrels themselves are machined identically, so you can just swap an Ultra CLX barrel for an R12 barrel and have no problems whatsoever. However, the finish and overall presentation of this barrel is much nicer. The rifling travels all the way up to the end of the barrel, and the rifling is finished off by a fairly nice factory crown. The lead is also finished better, and the rifling travels a little further back, so that when using his original pellet probe, the pellet is seated fully into the rifling rather than half and half. So it just goes to show that we were particularly unlucky with our particular R12, and that there are some good barrels out there. There's always going to be good rifles, and unfortunately there's always going to be a couple bad ones. However, after a little bit of work, I believe we've managed to save the barrel. With that all said and done, we'll bring it back over to the bench and we'll just take a very quick look at the groups. And here we have the groups that were done on camera. So hopefully from the groupings themselves you can see that the pellets are a lot more clustered and we're getting more accurate results. We are still getting a few flyers here and there, but that can be explained by just the magazine. We're using unweighed, unsalted pellets, so there may be some damaged ones in the tin, but overall I'm really quite happy with how the rifle's shooting. The average group size on this sheet is 18mm edge to edge. And if we compare it to one of the sheets we done earlier, so this one was how the rifle shot out the box. In this one, the edge-to-edge group sizes were about 25mm in diameter. So looking at them side by side, it's pretty much a different rifle entirely. So I'm really happy with how far we've come, and the rifle now is shooting rather well. There definitely still is some work to do on the rifle, as I want to have a good look over the magazines. So again, this sheet was done at 50 yards, but instead of using a magazine, we just thumb the pellets into the barrel. So some really nice tight groups. So I'm definitely going to have a look at the magazines and see if we can improve the rifle a little. But overall, I am really quite happy with how it's shooting now. But with that all said and done guys, that's pretty much going to do it for this video. So thanks for watching, and we'll see you in the next one.